Welcome humans. Today I discuss human interpretation of evidence. Firstly, avoid headlines and partial findings. Instead, observe the evidence with a critical eye. Human researcher bias can lead to practices, and the results, being reported in favor of that researcher bias. Challenge everything. Challenge the motivation of the evidence. Challenge the assumptions. Challenge the methodology. Look at where the data has come from, and whether the findings can be generalized to support a scientific hypothesis. Be aware of misrepresentation of facts. For example, it is common practice in political propaganda to report from various historical elections that may or may not be relevant, and to give bar charts with bar heights disproportional to the actual percentage. Some statistics knowledge will be required to evaluate descriptive statistics, tables, figures, data collection, study design and interpretation. For example, data shows evidence that there's a relationship between number of ice cream sales in a day and the number of shark attacks on humans in a day. This does not necessarily support a claim that ice cream causes sharks to attack humans. It is more likely that both are caused by an unreported third factor, the sunshine attracting humans to the beach. Question whether there is an intuitive or other mechanism for any observed findings. Scientific peer-reviewed studies are often considered gold standard, but these can be of differing quality and are subject to issues. I pass you to my human friend to discuss scientific publications.
At the lowest level of publication is opinion, followed by a single case study. At a higher level would be a controlled experiment. A meta-analysis compiling many relevant studies together for review is at the top, but even these are subject to publication bias. So some brief statistics talk. Publication bias is where studies reporting p-values less than 0.05 are chosen for publication. Notwithstanding the technical definition of a p-value, it can be seen as the probability of the results being observed by chance, with those p-values less than 0.05 considered as evidence of some phenomenon. This means that you often only hear about the significant results. There are a lot of publications with p-values that are only just below 0.05. So it can be a good idea to look for even smaller p-values. But do not just look at the p-value. Also look at the confidence interval and effect size, which measures the actual effect. So for example, in a study of weight loss, a p-value under 0.05 suggests that the difference is statistically significant. And the effect size represents how large the actual change in weight is. Look at the sample size. In the fitness industry, for example, conclusions can be based on very small samples. These are likely not to be adequate enough to make solid conclusions or be representative of the general population. So that's the end of the brief technical chat. You may not need to be able to understand every technical detail presented in a paper or other evidence. However, any procedures should be reported in enough detail so that they can be replicated. Read through the paper, check the presence of what you would expect to see in each section, such as theoretical underpinning and supporting literature. Ask questions like, is the evidence timely or is it outdated? Is it objective? What are the author's credentials? And is there a conflict of interests? Crucially, is the interpretation and discussion fitting with the information provided?
Thank you, human. A final important point. Humans are subject to confirmation bias. Humans actively search for evidence and interpret evidence in a way that affirms what they already believe. The vastness of the internet means that it is possible to find evidence supporting both sides. A good stance would be to source evidence from both sides of an argument and analyze it from a neutral position. Goodbye.